Okay, so next we kind of move away from simplifying and then proving that two things are actually the same. And so this one's a kind of a nice one to start with, and it might be obvious, and in fact, you can use this as one of your tools. Um, and so it is actually simplified. Cotan or cos over sine does simplify to cotan. But we're actually going to just prove that these are the same thing. And so this is the same as simplifying, but we're just kind of starting with one side. You can start with either side to like try to make them the same. But we're actually going to start with the simpler side, the cotan side. And the only reason why is because we want to like prove we have something to do there. And so you'll see how we're going to do that. Like we actually know what cotan is now. It's 1 over tan, and then we know tan has an identity. So like it just gives you more to do. And so we'll talk about some strategies over the next couple examples of how to prove these things. And so these guys are also called identities because they're true for every variable. Cotan's always cos divided by sine. And so like these are actually helpful. And we're going to talk about how to prove them. And so they're going to be used for solving complex trig equations later on in math. For now, like really, I would just enjoy them. They're kind of fun. Like we know what the answer is supposed to be. You're trying to like use some tools to make something else. They're almost like little puzzles. And so I know that's kind of corny for some people, but really, honestly, if you kind of embrace them like that and you just do practice that way, then you do better and like you do enjoy them more. This is probably one of my favorite things to do in high school was these proving trig identities. Okay, so we're going to start with the left side. And so it's important that we don't like kind of like we did in grade 9 where we proved left side is right side with equations. It's important that you don't like kind of use both sides of the equation, so you're not tempted to cross multiply or something. Like we're just looking at the question of cotan and trying to like see what it's equivalent to, and we trust that eventually we're going to get cos over sine. We've got to see how that happens still. We know cotan is 1 over tan. That's something from the reciprocals in lesson 2. What I do is like I actually use the division symbol because I'm going to actually sub in sine over cos for tan. And so the division symbol just is like a really more friendly way to divide fractions. You don't have to do this. Some people are no problem, but it is a nice strategy to use the division symbol. We're going to do 1 divided by sine over cos. Tan is sine over cos. Then this is a flip and multiply situation, cos over sine. And so 1 times cos over sine is just cos over sine, so it's equal to the right side. And this is our format. You can do it in like a T-chart. Some people have shown that equations are equal that way. Or you can just say LS for left side, left side, left side. And then eventually it'll equal the right side. Some strategies that we did was we changed tan into sine over cos so that you have same ratio on both sides. You have right side is cos and sine, so tan shouldn't be on the left. Like that just gives you a tool. Then another strategy is just using that division symbol. Next example, in terms of simplifying or why, like these are, it's hard to see why, but like this is an identity. It's true for every value of theta that's defined, at least. So I actually noticed that like something here when I look at the left side and the right side. And so we're not allowed to like kind of move things around, but we're allowed to like try to get one side to look like the other. And so if you look at these two denominators, and the denominators are a good strategy to look at, what can you do to one denominator make it the same? And so it's just like a common denominator strategy. We notice that the left side is actually the same as the right, except the right's squared. And so we're just going to multiply the top and the bottom of the left one to make it the same denominator, just a common denominator. And so we take the left side, which is this part here, and we just multiply in 1 minus sine so that we have the same denominator as the right side. Now this one's nice because like this is keep your brackets because this is a distributive law. But when you do the distributive law, it is a difference of squares, and so the middle terms are going to cancel out. So you get 1 minus sine squared. That's nice because like when you recognize 1 minus sine squared, it can actually factor to this. And so that's going to actually come up as a strategy later where you can change 1 minus sine squared into 1 minus cos squared. And in fact, that's probably what we would do if we started with the right side. we would change co-squared into 1 minus sine squared and then factor. But we're almost there. Left side, we've got 1 minus sine squared on the top. Now we know that sine squared plus co-squared is 1. And so then we know co-squared is 1 minus sine squared because we just move the sine squared to the other side, make it subtract sine squared from both sides, and it becomes 1 minus.
Hey, McBurney, please call extension 261.
And then, so then we've got the right side. We're done. Okay. And I think this is the last one. Sorry for the typo here. This should be cosine, not alpha. What this guy is, this alpha is just like theta. It's another Greek letter. When we're using multiple angles, we've used beta already before. We use different Greek letters, and so I just wanted you to be ready for that if you ever see something other than theta in there. So I'm actually going to start with the left side, and we're going to practice the strategy of factoring, which I talked about in the last one. So we know that the left side, the top is 1 minus sine squared, or 1 minus cos squared, similar to the last question. And then similar to the last question, but backwards, the top factors to a difference of squares.
Jill Milrose, call extension 210, please. Jill Milrose, call 210.
So we get 1 minus cos, 1 plus cos. Sorry about the announcements. It's a snow day, so it's just announcements all the time. 1 minus cos, 1 plus cos. And then the bottom is 1 minus cos. And so then we see that we have the same factor on the top and the bottom, which can cancel out. And we're left with 1 plus cos, which is actually the same as the right side, just there was a typo. And then there's practice.